one in that first batch. Like I said, I did have a request for it. All right. So basically, number one in triangle ABC, measure of angle A is 40, C is 70, and BC equals 8.5. So you can draw in, all right, the vertices anywhere you'd like. Not going to affect what you do for the answer. So it says A is 40, C is 70, and BC is 8.5. The nearest length, what is AB? AB is this segment over there. It's opposite to C. That's a little c over there. All right. So depending upon whether you put the sign on the top or the bottom, sine 70 over c equals the sine of 40 over 8.5. And then you cross multiply 8.5 times sine 70 divided by sine 40. And that comes out to be approximately 12 point. All right, so if they don't give you a diagram, you just include the diagram. All right, again, it doesn't have to be drawn to scale. You can draw it equilateral all you want. You're just going to put sides where you need them to be. All right, so there is 1 through 10. You want to take a look, see. So there, oops, let's go 1 through 8. So there is 1 through 8. Put it back up. Boom. Okay, so numbers 2 and 3. Numbers 2. All right, number 2, triangle PQR. All right, measure of angle P is 33 degrees. Measure of angle Q is 82 degrees. And PR is 14.2. The nearest 10th, what is the length of QR, which is over here, which is little letter P? All right, so sine 33 over P equals sine of 82 over 14.2. I'm going to cross multiply 14.2 times sine 33, divide that by sine 82. And I get my 7.8. All right. Okay, when I look at number 3, triangle THK, says G is 105, K is 32, and GH is 10.2. The nearest 10th, what is GK, which is over here? The difference is that it's not opposite the 105, so you need to use the triangle angle sum, add these up. 105 plus 32 is 137. Subtract that from 180 and I get 43. So the sine of 43 over little h equals the sine of 32 over 10.2. Since the 10.2 is opposite the 32-degree angle, I'm now going to do 10.2 times the sine of 43. I divide that by sine 32. And that gives me the 13.1. All right. Yep. All right. So any others? Everybody's good? There we go through 12. All right. Scroll down a little more through 14. Covers the first page. How did you get y for number 10? Okay, so number 10. Let me draw it out, and then I'll go back to that. So x 17, 13, and y. Right. Okay. So, okay. So, sine of x over 13 equals the sine of 32 over 17. All right, and then the second sine of that cross multiplication gave me that to be, make sure I got this right, good, 23.9 degrees. Now, we asked about y. Basically, these two are two angles of a triangle. To get that angle, I'm going to add these two together to give me 55.9. Subtract that from 180, and that angle measures 124.1. All right, so I'm going to go to my other side of the sine 32 over 17, and I'm going to put the sine of that angle, which is 124.1 over y. I'm now going to cross multiply 17 sine 124.1. I'm going to divide that by the sine of 32. And y comes out to be 26.6. All right, so basically you need to use that angle, all right, in order to get that. All right. For 13, to get y, I got 75 and 39, x and y and the 24. All right. So if I add these up, 75 and 39 is 114. Subtract that from 180, I get 66. All right. So the sine of 66 over 24 is going to go in the middle. Equals the sine of 75 over y. Equals the sine of 39 over x. All right. So we're focusing on, we asked about the y part, so we're going to do 24 sine 75. And divide that by sine of 66 when we're cross multiplying. And that gives me 25.4. All right. And then for 14, similar idea, 8.6, 7.3, y, x and 32. All right, sine x over 7.3 equals sine 32 over 8.6 equals, that's how I'm going to get x. So I'm going to do 7.3 times the sine of 32. And divide that by 8.6. So the sine of x equals 0.4498. I'm now going to hit second sine and put in the 0.4498. That gives me 26.7 degrees for y. Now to get this angle up there, I'm going to add these two together and subtract from 180. That gives me 121.3. So now I'm going to go back. Sine of 121.3 over y equals sine of 32 over the 8.6. And I'm going to do the same thing and multiply sine of 121.3 times 8.6. I'm going to end up dividing that by the sine 32. And I get y is equal to 13.9. All right. Word problems, the joy of joy. There's 15 through 17. All right. All right, so we got some requests for number 15, so here we go. All right, so there's our triangle for number 15. All right, they give us this angle over here, which is 65, makes that angle 115 by linear pairs. All right, and since they give me that side, I need that angle up there, so I add these up, 115 and 37 is 152, subtract it from 180 and I get 28. All right, so that's going to be my middle proportions, or sine 28 over 800 equals. Now I'm trying to get the distance, it says, from point A, which is there, to the balloon, which is up there. So I need that distance there. The angle opposite that is the 37, so sine 37 over x. Where did I get 115? They form a linear pair. So they add up to 180. All right, they add to 180. So you just subtract from 180. No problem. Okay, so now we're going to do 800 times sine 37, right? It's 800 feet. All right, 800 sine 37. All right, and I divide that by sine 28. And I get 1025.5. When I do that calculation, and they say to round to the nearest foot, so that's why I end up with 1027. All right, good enough. Good questions thus far. Anybody have an issue with either 16 or 17? Everybody's good with 16 and 17? Going once, going twice. So then there's 18 through 21. All right, so we got an 18 and a 21. 25 and B is 50. BC. All right, and then in 18, they tell you BC is 6.2. And in 21, they tell you AB is 27. Okay. So in the beginning of the problem, they tell you A is 25 degrees and B is 50 degrees. So you fill those in. Now, triangle angle sum says they add up to 180. 25 and 50 is 75. Subtract that from 180 and you get 105. You're going to need that in the second one to get that segment. Okay, definitely. I don't know about the first one yet. So it says in this, BC is 6.2. They want to know what is the length of AC. All right, so opposite AC is the 50 degrees. So sine 50 over little b, that's what AC is, equals sine 25 over 6.2. That's the one segment they give me in this problem. All right, so that's what I want to make sure I get. So now I'm going to do 6.2 times sine 50. And I'm going to divide that by sine 25. Okay. Yeah. All right. All right, so 6.2 sine 50 divided by sine of 25. And I get B for that one to be 11.2 when I do the cross multiplying. And the one underneath, all right, they tell me AB is 27.3. They want to know what is BC, which is little a. Capital A is 25, so the sine of 25 over little a equals, they give me the 27.3, so the angle opposite of that is the 105. The sine 105 over 27.3. I'm going to cross multiply 27.3 times the sine of 25. Divide that by the sine of 105. Divide that by the sine of 105. And I get 11.9. Okay. So there you go. No problem. All right. So I think that covers all of them. Everybody good? All right. So just so you know for the quiz, and we'll talk more about it on Friday when we review for it. All right. You'll have one where you have to find a side, one where you have to find an angle, one word problem. All right. And go from there. So basically, and then we're going to show you what work you need to show in terms of your ratio. So that gives you an idea of the upcoming quiz on Monday. All right. So now we're going to talk about congruence in right triangles. Now we're going to talk about congruence in right triangles. So we're going back to section 4.6 in our textbooks. All right. Because this is going to make a lot more sense after we did Pythagorean theorem. It connects it a lot better. All right. Our ambition today is to prove right triangles specifically. Right triangles congruent using what we call the hypotenuse leg theorem. Using the hypotenuse leg theorem. All right. So basically what it looks like is this. We have two right triangles, and they have to be right triangles. This doesn't work for anything else except the right triangle. And what they will give you is one leg and the hypotenuse, which, if it wasn't a right triangle, would be side-to-side angle, which normally doesn't work. You will learn in trigonometry why it doesn't work. So why it does work for this particular situation? Yes, it will be. The new lesson we are learning will be on the quiz. So this is the second part of the quiz, which will be on Monday. All right. So I'm bouncing back and forth here. All right. So this will be on the quiz as well. All right. And basically this works because if that's congruent to that and that's congruent to that, when we do a squared plus b squared equals c squared, we have the a and the c, which the numbers are going to be the same. That way the b is identical. That's why it works. Because they're right triangles. Basically, Pythagorean theorem is why it works. All right, so that's why it works. All right. So theorem 4.6, if the hypotenuse and the leg of one right triangle are congruent, the hypotenuse and the leg of another right triangle, then the triangles are congruent. All right. So there's three conditions though. Number one, it must be right triangles. So you have to make sure, and that's the major thing, you don't prove the angles are congruent, you prove that the angles are right angles. All right? So that's what you need to do. The hypotenuse must be congruent. There's one pair of congruent legs. So basically what we have is PQ is parallel to RS. RP is perpendicular to PQ. QR is congruent to PX. All right? We have to prove angle S is congruent to angle Q. Now, from earlier in the year, hopefully you remember whenever we're proving segments or angles are congruent, our proof's going to end with CP, CP6. All right? So now I have to say, all right, these are the hypotenuses. I need a leg. Okay? Well, basically, the leg, all right, is the shared side. So I got my hypotenuse and my leg. Now I need my right angle. They're giving me this right angle, which comes from RP is perpendicular to PQ. That's going to be a right angle based upon definition of perpendicular lines. Okay? Now, there's other ways of going about this part, but we also need this to be a right angle. All right? Well, there's two ways of going about it. Number one, the long way would be to say that these two are alternate interior angles. So you would have to say that angle SRP and angle QPR are right angles. The short way is we can say these are right angles based upon what we did at the end of chapter 3. At the end of chapter 3, we said lines perpendicular, parallel lines are perpendicular to the same line. So that's how we're going to give this. All right, so we start writing our proof. PQ is parallel to RS. RP is perpendicular to PQ. That is given. All right. That means we're allowed to say that RP perpendicular to RS. Parallel lines are perpendicular to the same line. Parallel lines are perpendicular to the same line. All right. So now this is important, ladies and gentlemen. You now have to say that angle PRS and angle QPR are right angles. And that falls under the definition of perpendicular lines. Otherwise, you cannot use hypotenuse leg. It's great that they're congruent, but if you don't mention that they're right angles, it's a flaw in your argument. and you're going to lose points. All right. QR was congruent. All right. QR was congruent to PS because it was given. PR is the shared side, so PR is congruent to PR. Reflexive property or shared side. All right. Triangle PRS congruent to triangle RPQ. HL theorem. Not a postulate, it's a theorem. And then finally, that brings us to angle S congruent to angle Q. DPCTC. All right. All right. Looking at the next one, we'll just set that up. BC is perpendicular to AC. BD is perpendicular to AD. AC is congruent to AD. All because it is given to you. All right. Again, please do not forget, angle C and angle D are right angles. Not that they're congruent, they are right angles. Definition of perpendicular line. Definition of perpendicular line. Just like in the last one, AB is congruent to AB. Reflexive property. All right. Triangle ACB, congruent to triangle ADB. Hypotenuse leg theorem. If you don't write theorem in the homeworks, it's okay, but you are going to need to be able to do that on the quiz. So now we want to say AB bisects CAD, so that angle's there. So we go back to what we did earlier in the year. We can name them with numbers to make our lives easier. Angle 1 is congruent to angle 2 by 5 magic letters, CP, CTC. And that allows us to say AB bisects angle CAD. Definition of angle bisect. All right. Tomorrow in class, we will go through the remaining 5 proofs to give you an idea with that. Don't forget this evening, one classwork. All right, your only homework this evening is the area using signs assignment. Shouldn't take you long at all. It's 12 problems. All right, you just have to show 1/2 AB and then the sign of C and then your answer. We'll go through those quickly tomorrow. All right, and then like I said, we will finish the proofs. All right, anybody have any questions? Everybody's good? All right, well, have a good day. We will see you tomorrow. I'll be available at 1:40 if you have any questions about any of the homework or this stuff coming up. Otherwise, stay safe. We'll see you tomorrow.